Hi everyone, welcome. Thank you for joining my talk, Assumptions and Adventures in Nomad Autoscaling. My name's James, you may know me online as Rasell, and I work on the Nomad ecosystem team. Alongside me, Louise, Jasmine, but this is just the engineering team. There are a lot of other people involved. We have the marketing team, management, education, sales, everyone is involved in helping make this product. And we also have a great community. They provide us with great feedback, and they also help drive feature development. So thank you to everyone involved with that. So our team's primary, or one of our primary responsibilities, is the Nomad Autoscaler. This is, as it says, how to autoscale your workloads and your clusters. The Nomad Autoscaler supports 3 different and distinct types of autoscaling. The first is the most traditional. This is horizontal app scaling. So this is where we increase or decrease the number of instances of your application in order to meet SLAs, in order to handle the traffic that you have. The second is horizontal cluster scaling. So when we're scaling your app in and out, you want to have either the headroom so you can scale, or you want to make sure that you're cost effective and that you're not using servers that you don't need. And so horizontal cluster scaling is the addition or removal of nodes in your cluster. The third one is our enterprise offering. This is vertical application scaling, or what we term dynamic application sizing. Picking CPU and memory resource values for your jobs is kind of tricky, and it's generally a ballpark figure. What DAS does is it looks at historical data and tries to give you recommendations, and so that you don't have to worry about that, and so that you're as efficient as possible. DAS is a very large topic. I won't be going into much of that today, but if you're interested, please reach out. And so how do we support these 3 types of autoscaling in a single application? Well, like many products at HashiCorp, we use Go plugin. Go plugin is an RPC plugging system over NetRPC or gRPC. It allows us to define interfaces, and then we can develop plugins either internally or externally, so it kind of decouples the process and means we can develop fast, as well the community can contribute without much effort. And so this was the ecosystem 1 year ago. I used this slide last year at HashiCorp, and we only supported horizontal application scaling. It had limited flexibility, and the target plugin itself was just Nomad. It did its job well, but it wasn't very flexible. And so this is where we are today. This diagram might even be out of date at this point in time, and I'll have to come up with a new way to demonstrate how it looks. But as you can see, we've had a huge growth in plugins. We now support a wide variety of cloud providers, server providers, and a lot of this has been driven by the community, so thank you again. We've also had a recent focus on our strategy plugins. Target Value was a good plugin, but it was tricky to use in some circumstances. So we now have pass-through, threshold, and fixed value. And I'll go into a couple of those in a bit. And so let's get on to some assumptions and some adventures in autoscaling. And the first one is, autoscaling is easy. Cloud providers have done a really good job of kind of making it a commodity service. And as developers, our job is to present it easily for you to understand. But implementing an autoscaler is really tricky. That also goes for implementing autoscaling in your application. Even adding autoscaling to one app is hard. And so autoscaling can uncover unknown behaviors in your application. The core, when you're implementing autoscaling, is to understand the metrics which determine how your application scales, right? Traditionally, this may be CPU or memory based, but they're not great indicators. So you might look to use latency, which is a direct metric for your users. But it's a trailing metric, so by the time that metric is alerting, it might be too late, your users might go elsewhere. And then what happens when we do start to scale your application up and down? We might uncover bottlenecks, particularly as we scale your application out. Maybe you start to exhaust the pool of connections you have to your database. Even things like log, metric, ingress can increase in costs, they can increase in network traffic, and it kind of uncovers this unknown behaviors. And then what happens when we're scaling your application in? Well, maybe your application needs to perform certain shutdown routines. Maybe your application needs to deregister itself from somewhere. Maybe it wants to make sure its connections are closed properly. And so having your application kind of listen to the signals it's getting, perform the shutdown properly is very critical. It can result in a bad user behavior. Outside of your application code, Nomad can try and help you here. Here we have some task standard parameters that can be helpful. The first is the kill timeout. This specifies the duration to wait when Nomad's waiting for your application to shut down gracefully before it kills it. This has a fairly short default of about 5 seconds. That is okay for most applications. But if your application is on that threshold when shutting down or above that, definitely increase this. The second is the kill signal, mildly useful, less so than kill timeout. This specifies a configurable kill signal. So if your application is doing something weird, then use that. If application scaling is tricky, cluster scaling is just plain hard. Scaling out, we can lean on the provider. But scaling in, we really have to make a series of calls in sequence and correctly and ensure there's no errors. The first one is the node selection. We need to make sure we pick appropriate nodes for you. We don't want to churn work or result in a lot of progress in hours of days of processing to be cut and have to be restarted. Then we have node draining. Node draining is the process of migrating all the work off that node. Again, this links into your application listening to signals. We also need to provide feedback. This activity can last hours. And so understanding what applications are waiting to be drained, what have drained, if there's any problems, is important. And the last one is node termination. So node termination is the act of talking to the provider and saying, please remove this, terminate this server, terminate this node. That has to go across unstable, unpredictable networks. There can be errors there. Also, we have options of running additional tasks after node termination, such as node purge from the GC. And so this is in itself a number of calls that we have to make and make sure there's no errors. The Nomad job spec has this migrate stanza, which is aimed at helping control draining nodes and your jobs in particular. Max parallel is the number of allocations that we can migrate at the same time. So if you have 5 allocations of a job, maybe 1 is fine. If you have 1,000, 1 might be a bit slow, and so you might want to up that. The minimum healthy time is the time which an allocation that's been migrated, when it comes back up, it must be healthy before it blocks further allocation migration. That is useful in the sense that if your app takes a minute to come up, warm up, do some work, just set that a little higher. The healthy deadline as well is the time in which Nomad will allow this allocation to become healthy. If your allocation takes a minute, your app should take a minute to start, then 2 minutes is a good value to set. Means it's probably not going to come back up in time. And then on the Nomad Autoscaler side, this is a kind of example from a cluster scaling policy, a particular targeting the target plugin section, the Azure VMSS section. And the node drain deadline specifies how long to wait for allocations to finish migrating. If all the allocations haven't finished by migrating by this time 1 hour, Nomad will forcefully kill them. The second one, the node select strategy, is something that we've added recently. And this is changing the behavior of how we pick nodes to terminate. We currently have 4 options available. We have the least busy. This looks at the amount of allocated resource on each node and picks the ones with the least amount. It's not to be confused with utilization. The second is newest create index. This is just the order that we get it back from Nomad. It's the least computational heavy because we don't have to do any sorting. We then have empty and empty ignore system. These will only pick nodes which are not running any allocations or not running any allocations which aren't system jobs. These are perfect for something I will talk about in a minute. And this brings me on to the idea that autoscaling is only useful for services. It's true, it's very useful for scaling services, and it's usually the first port of call when you adopt autoscaling, but it's very useful for other types of work, in particular batch work, and it's an area we've been working on a lot recently. Autoscaling for batch work, scale to and from 0, is a great idea, right? Batch jobs are kind of expensive sometimes. They use special hardware, CPU, high memory, or GPUs. And they generally have a running time which isn't forever, right? They maybe run for an hour or a couple of days. AWS, their G3 class, the second lowest instance in that class costs $1.1 per hour. That's $10,000 per year for one instance. You're probably going to be running more than one instance. You could spin that infrastructure up manually with Terraform, but even that's costly. It's error prone, and it takes away human time that could be better spent elsewhere. Also focusing on AWS, ASGs don't cost anything when they don't have any instances running. So why take the effort to always spin up that infrastructure, spin it back down when we can have the autoscaler do that for you? And so this is a shortened example of what a batch scaling policy might look like. We have the source of Prometheus, and in this example we're going to assume that the query returns the absolute result. So per allocation that we're going to run, maybe it requires one GPU, and each instance that we are running has one GPU, so we have one allocation per instance. And so the number of running and pending is the number of instances that we want to have running. Therefore, this new strategy that we have, pass-through, doesn't do any more computation on that value, on the query result. It takes that value and passes it straight through to the target. And then in the node selection, we can use empty. We don't want the autoscaler to prematurely remove nodes that are running work. Say if this batch work, this encoder job is 90% of the way through and we migrate that work off, it has to start from 0 again. So this helps avoid that. And this is kind of a quick example of how that might look. We have the platform ASG that could run our long-lived services such as our Grafana, our Prometheus, and most probably our Nomad Autoscaling. We then have the batch ASG. That's currently set to 0 instances, so not costing anything, not running anything. And we have our kind of work queue where the work gets submitted to. And so what can happen? We have work that's submitted, we have these encode jobs that turn up, and the autoscaler will look at that, grab the query and say, okay, we need 2 instances running to handle this work. And so what happens as those instances come online, we take that work out of the queue. And because we're using the node selector strategy of empty, the autoscaler will not select any of those nodes to terminate until the work is finished. And as that work finishes, we gradually move that work off, and we're left back to where we were. So this can use external metrics. Nomad 1.1.0 also added additional metrics regarding blocked work. And so there's a couple of ways that you can achieve this. And I'll share later a link to a demo where we demo this batch work scenario in AWS, excuse me. And so then to the final idea that autoscaling doesn't really suit multi-cloud. It's true in the traditional sense of cloud providers have their own service and it will interact with other services of their own. But Nomad has a great multi-region, multi-federation story where multi-cloud is a viable option. And so it's something we talk about internally quite a lot and something that we believe there's definitely a future in. And so one of the ideas is cloud bursting from on-premise. And you might say, but everyone runs in the cloud. Not particularly, no. There might be a number of reasons why that you might have on-premise workload at the moment. You might have a long-running contract that you need to see through. You might have expensive hardware that you still want to utilize. You might be in the process of doing your cloud migration. These cloud migrations can take a number of years. And so on-premise can form your base of compute, right? It can perform all the long-running services that are critical to you, your monitoring, your log aggregation, maybe some of your ingress. But what happens if your workload exceeds the capacity? It will probably take you weeks to order a new server, rack that server, configure it, and by that time it's far too late. It's wasted money. And so why not use the elasticity of cloud to help you when you need? It's much like the batch demo that I previously talked about, where the platform autoscaling group is your on-premise, your long-running infrastructure, and the batch autoscaling group is the cloud elasticity that you use just when you need some spillover. And then multi-cloud autoscaling. So Cloud environments are very complex distributed systems. Outages can occur. So what happens if your primary provider is having an issue? You can migrate to another region, but that's often tricky. It kind of falls into a thundering herd problem where everyone's doing it at the same time into the same region because it's the next closest. Even some services can fail completely in cloud providers. AWS IAM, if that's having problems, then it might impact the entire provider. So maybe you want to scale to a different provider just to weather out these availability issues. As well, most of the major providers offer a kind of spot market where you can utilize unused compute at a fraction of the cost, 80% of the normal cost. And so maybe you have work that suits this. Maybe you start 10,000 allocations in your primary provider and they run, and then suddenly the spot price of the particular instance you're interested in, maybe that raises because it's becoming popular and it becomes too expensive compared to another provider. And then what you might want to do is run 10,000 allocations of the next batch on a different provider and just get that cost effectiveness that is critical for business. If you're interested in finding out more, I will share these links in chat. If you have questions, please reach out to the Discuss forum. We have guides, demos. If you come across any issues or want to contribute, we're always happy to chat. We're always happy to talk and to listen. We also have a blog post which details some of the recent work we've been doing around the strategy plugins. So please head over and read that. Thank you for listening. I hope you enjoy the rest of the conference. And again, if you have any questions, feedback, or just fancy a chat, please let me know.